Emergency lighting in stairwells and egress routes typically requires battery backup to comply with safety regulations. While a generator is a valuable component of an emergency power system, relying solely on generator power for emergency lighting in these critical areas may not satisfy code requirements. The primary reason for requiring battery backup is to ensure immediate illumination in the event of a power failure. Generators, although reliable, require a certain amount of time to start up and reach full operational capacity. This delay, even if it's only a few seconds, can create a hazardous situation in stairwells and egress routes where immediate visibility is essential for safe evacuation. Battery backup systems provide instantaneous illumination, bridging the gap between the moment of power loss and the generator's activation. Building codes and electrical standards, such as the National Electrical Code, often mandate battery backup for emergency lighting in specific locations, including stairwells, exit passageways, and areas serving as means of egress. The rationale behind this requirement is to provide a reliable and immediate source of light, allowing occupants to safely navigate these areas during an emergency. Generator power is often acceptable as a secondary or supplementary power source for emergency lighting, but it typically does not replace the need for battery backup. The generator's role is to provide extended power during prolonged outages, ensuring that emergency lighting remains operational for the duration of the emergency. However, the initial period immediately following a power failure must be covered by battery backup to guarantee immediate illumination. There are several factors that influence the specific requirements for emergency lighting battery backup. Firstly, local building codes and regulations may have specific mandates regarding the type, duration, and placement of emergency lighting in stairwells and egress routes. It's essential to consult these codes to ensure compliance. Secondly, the occupancy classification of the building can affect the requirements for emergency lighting. High occupancy buildings, such as hospitals and large office buildings, may have more stringent requirements than low occupancy buildings. Thirdly, the design of the stairwell and egress routes can also influence the placement and type of emergency lighting. Areas with limited natural light or complex layouts may require more extensive emergency lighting systems. Battery backup systems for emergency lighting typically consist of a battery, a charging circuit, and an inverter. The battery stores electrical energy, the charging circuit maintains the battery's charge, and the inverter converts the battery's direct current (DC) output to alternating current (AC) to power the lighting fixtures. The duration of battery backup required by code varies, but it's commonly 90 minutes. This means that the battery must be able to power the emergency lighting fixtures for at least 90 minutes in the event of a power failure. The sizing of the battery is determined by the load of the emergency lighting fixtures and the required duration of backup power. The emergency lighting fixtures used in stairwells and egress routes are typically designed to be energy efficient and provide adequate illumination. Light-emitting diode (LED) fixtures are commonly used due to their long lifespan and low energy consumption. These fixtures are often equipped with lenses or reflectors to distribute the light evenly and minimize glare. Regular testing and maintenance of emergency lighting systems are crucial to ensure their proper operation. Testing involves simulating a power failure to verify that the battery backup system activates and provides illumination for the required duration. Maintenance includes inspecting the batteries, charging circuits, and lighting fixtures for any signs of damage or malfunction. Proper documentation of testing and maintenance activities is also important for demonstrating compliance with code requirements. In conclusion, while a generator can provide valuable backup power for emergency lighting, it typically does not replace the need for battery backup in stairwells and egress routes. Battery backup systems provide instantaneous illumination during the critical period immediately following a power failure, ensuring the safety of building occupants. Compliance with local building codes and electrical standards is essential to ensure that emergency lighting systems meet the required performance criteria. The National Electrical Code, or NEC, addresses emergency systems in Article 700. This article provides requirements for the installation, operation, and maintenance of emergency electrical systems, including emergency lighting. Section 700.12 of the NEC specifically addresses the sources of power for emergency systems. It outlines the acceptable power sources, including batteries, generators, and uninterruptible power supplies (UPS). This section also specifies the requirements for the transfer of power from the normal power source to the emergency power source. For example, it specifies that the transfer must occur within a certain time frame to ensure continuous operation of the emergency system. Battery backup systems used for emergency lighting must comply with specific requirements outlined in the NEC. Section 700.12, Part E of the NEC addresses battery requirements. This section specifies the type of batteries that are permitted for use in emergency lighting systems, such as lead-acid batteries or nickel-cadmium batteries. It also specifies the required capacity and voltage of the batteries, as well as the charging and maintenance requirements. Generators used as an emergency power source must also comply with specific requirements outlined in the NEC. Section 700.12, Part B of the NEC addresses generator requirements. This section specifies the required capacity and performance characteristics of the generator, as well as the installation and maintenance requirements. It also specifies the requirements for the transfer switch that automatically switches the load from the normal power source to the generator in the event of a power failure. In addition to the NEC, other codes and standards may also apply to emergency lighting systems. For example, the International Building Code, or IBC, contains requirements for emergency egress lighting. The IBC specifies the required illumination levels, the placement of emergency lighting fixtures, and the duration of emergency lighting. Furthermore, local building codes and regulations may have additional requirements for emergency lighting systems. It is important to consult with local authorities to ensure compliance with all applicable codes and standards. Proper design, installation, and maintenance of emergency lighting systems are crucial to ensure their reliability and effectiveness. Emergency lighting systems should be designed by qualified professionals who are familiar with the applicable codes and standards. The installation should be performed by licensed electrical contractors who are experienced in installing emergency systems. Regular maintenance, including testing and inspection, is essential to ensure that the emergency lighting system is in proper working order. Emergency lighting systems should be tested at least annually to verify that the batteries are fully charged and that the system operates as intended. The battery should be replaced periodically as recommended by the manufacturer. Lighting fixtures should be inspected regularly to ensure that they are clean and in good working order. Any deficiencies should be corrected promptly to ensure the reliability of the emergency lighting system. To further explain the concept of battery backup, consider a scenario where a building experiences a power outage due to a severe storm. The normal power supply is disrupted, plunging the building into darkness. However, the emergency lighting system, equipped with battery backup, immediately activates, illuminating the stairwells and egress routes. This immediate illumination allows occupants to safely navigate the building and evacuate if necessary. Without battery backup, there would be a delay in illumination while the generator starts up. This delay could create confusion and panic, potentially leading to accidents and injuries. The battery backup system ensures that occupants have immediate visibility, enabling them to safely exit the building. The generator then kicks in, providing continuous power to the emergency lighting system for the duration of the outage. This ensures that the stairwells and egress routes remain illuminated even if the power outage lasts for several hours. The combination of battery backup and generator power provides a reliable and comprehensive emergency lighting solution. The battery backup provides immediate illumination, while the generator provides extended power during prolonged outages. This combination ensures the safety of building occupants in the event of a power failure. In addition to providing illumination, emergency lighting systems also play a crucial role in guiding occupants to safety. Emergency lighting fixtures are often equipped with directional signs that indicate the location of exits. These signs help occupants to quickly and easily find their way out of the building during an emergency. The placement of emergency lighting fixtures is carefully planned to ensure that all stairwells and egress routes are adequately illuminated. Fixtures are typically located at key points such as landings, intersections, and doorways. The illumination levels are designed to provide sufficient visibility without causing glare or discomfort. Emergency lighting systems are an essential component of a comprehensive life safety plan. These systems provide immediate and reliable illumination during power outages, enabling occupants to safely evacuate a building. Compliance with building codes and electrical standards is crucial to ensure that emergency lighting systems meet the required performance criteria. The NEC and the IBC provide detailed requirements for the design, installation, and maintenance of emergency lighting systems. It is important to consult with qualified professionals to ensure that emergency lighting systems are properly designed and installed. Regular testing and maintenance are also essential to ensure that these systems are in proper working order. By investing in emergency lighting systems, building owners and managers can help to protect the safety of their occupants and minimize the risk of accidents and injuries during emergencies. Furthermore, compliance with code requirements can help to avoid costly fines and penalties. Emergency lighting is a critical component of a building's overall safety plan. While generators provide long-term power during outages, battery backups offer the crucial initial illumination needed for safe evacuation. Understanding and adhering to relevant codes and standards is paramount in ensuring the safety of building occupants during emergencies. Now, let's consider some specific examples of how battery backup is used in emergency lighting systems. In a typical office building, emergency lighting fixtures are installed in stairwells, hallways, and near exit doors. These fixtures are connected to a battery backup system that is designed to provide at least 90 minutes of illumination in the event of a power failure. When the power goes out, the battery backup system automatically switches on, providing immediate light to guide occupants to safety. In a hospital, emergency lighting is even more critical. Hospitals must maintain continuous power to critical equipment and systems, including life support systems and operating rooms. Emergency generators are used to provide backup power to these systems, but battery backup is also essential for providing immediate illumination in patient rooms, hallways, and stairwells. In a movie theater, emergency lighting is required to guide patrons to safety in the event of a fire or other emergency. Emergency lighting fixtures are installed throughout the theater, including in the aisles, near exit doors, and in the lobby. These fixtures are connected to a battery backup system that provides immediate illumination, allowing patrons to safely evacuate the theater. In a school, emergency lighting is essential for ensuring the safety of students and staff. Emergency lighting fixtures are installed in hallways, classrooms, and near exit doors. These fixtures are connected to a battery backup system that provides immediate illumination, allowing students and staff to safely evacuate the building. In a high-rise apartment building, emergency lighting is critical for guiding residents to safety in the event of a fire or other emergency. Emergency lighting fixtures are installed in stairwells, hallways, and near exit doors. These fixtures are connected to a battery backup system that provides immediate illumination, allowing residents to safely evacuate the building, often descending many flights of stairs. These examples illustrate the importance of battery backup in emergency lighting systems. Battery backup provides the immediate illumination needed to guide occupants to safety in the event of a power failure. Without battery backup, there would be a delay in illumination while the generator starts up, which could create a dangerous situation. In addition to providing immediate illumination, battery backup systems also offer other benefits. Firstly, battery backup systems are relatively inexpensive to install and maintain. Secondly, battery backup systems are reliable and require minimal maintenance. Thirdly, battery backup systems can be easily integrated into existing emergency lighting systems. When selecting a battery backup system for emergency lighting, it is important to consider the following factors. Firstly, the size of the area that needs to be illuminated. Secondly, the required duration of illumination. Thirdly, the type of lighting fixtures that will be used. Fourthly, the local building codes and regulations. It is also important to choose a battery backup system that is certified by a recognized testing laboratory such as Underwriters Laboratories or UL. UL certification ensures that the battery backup system meets safety and performance standards. Regular testing and maintenance of battery backup systems are essential to ensure that they are in proper working order. Battery backup systems should be tested at least annually to verify that the batteries are fully charged and that the system operates as intended. The batteries should be replaced periodically as recommended by the manufacturer. Lighting fixtures should be inspected regularly to ensure that they are clean and in good working order. Any deficiencies should be corrected promptly to ensure the reliability of the emergency lighting system. Emergency lighting systems are an essential component of a comprehensive life safety plan. These systems provide immediate and reliable illumination during power outages, enabling occupants to safely evacuate a building. Compliance with building codes and electrical standards is crucial to ensure that emergency lighting systems meet the required performance criteria. The NEC and the IBC provide detailed requirements for the design, installation, and maintenance of emergency lighting systems. It is important to consult with qualified professionals to ensure that emergency lighting systems are properly designed and installed. Regular testing and maintenance are also essential to ensure that these systems are in proper working order. By investing in emergency lighting systems, building owners and managers can help to protect the safety of their occupants and minimize the risk of accidents and injuries during emergencies. Furthermore, compliance with code requirements can help to avoid costly fines and penalties. In conclusion, emergency lighting in stairwells and egress routes must have battery backup to meet safety standards and provide immediate illumination during power outages. While generators are helpful for extended power, they cannot replace the immediate response of battery systems. Compliance with codes like the NEC and IBC is crucial for ensuring the safety of building occupants.